And here's day 4 of the competition math problem series that I'm developing. There's, again, this first problem, it is always a problem for a quiz bowl type competition where the problem is read verbally. So that's why I wrote it in this specific way. And I'll kind of explain it here in a minute. And then the second problem is a little bit more difficult. Typically, you have to think outside the box a little bit to figure those out. It's on a handwritten test. So good luck. All right, for the first problem, it's written or it's listed verbally, and you have to answer it without a calculator. And the first team to win answer it correctly is right. So it would generally in a textbook be written something like this: f of x equals x to the fourth power plus 2 times x squared plus 7. And then it asks, what is f at 2 minus f at negative 2? That's generally what you're used to seeing it. Now notice the big difference. I'm saying f at the value of x. Sometimes you'll hear that as f of x or f of the value x. I try to avoid the use of because it typically means multiplication is confusing to kids. And at the competition, they did read it f at the value of x, so I kept it the same. Excuse me. So when you plug this in, it's just a matter of your function notation, plugging this thing in. You could probably surmise that it's probably 0 if it's an even or odd function, something like that, maybe quicker. But if you just plug and chug like I'm used to doing, it would be 2 to the fourth plus 2 times 2 squared plus 7 minus, you'd find that value, minus negative 2 to the fourth plus 2 times negative 2 squared. And at this point, you probably know the answer 0, hopefully. Because all of this would be 16 plus 15, 16, not 15, but 16 plus 8. 2 squared is 4, times 2 is 8, plus 7. That's where the 15 comes from. And so this is 16 plus 15, which is 31, minus, this would be exactly the same. I should have brackets around this. So it's minus 16 plus 8 plus 7. So it's exactly the same thing. So you're going to have 31 minus 31, which is 0. And, the quicker you figure that out, probably the possibility that you get that correct before somebody else. All right, so that's problem 1. Problem 2 here is a little bit more challenging. So 2 players flip 3 fair coins each. What is the probability that they get the same number of heads? Okay, this one, I love this problem because I think of it like the dice problem. But the first thing you got to think about is how do you come up with, if one person flips 3 coins, how many possibilities are there? Well, you could get all tails, or you could get one head, which would be head, tail, tail, or tail, head, tail, or tail, tail, head, where you get the head on the third flip. You could have 2 heads. You could have head, head, tail. You could have tail, head, head. You could have head, tail, head. Or you could have all heads. So 3 heads, head, head, head. And so there's 8 possibilities. That's the whole sample space. You could also think of it in the fundamental counting theorem. There's 2 choices for the first coin, 2 choices for the second coin, 2 choices for the third coin. So there's 8 possibilities. So that's one part of this you need to understand. And so both people have 8 choices basically that they can have, 8 outcomes. And so I love to think of this like the dice problem. But instead of dice, we've got coins. And so I'm just going to represent it here. So player 1 would be all open. This would be a tail, tail, tail. You could have head, tail, tail. Well, dang it, I filled it in and didn't mean to. But you could have head, tail, tail. You could have tail, head, tail. You could have tail, tail, head. You could have tail, tail, or head, head, tail. Excuse me, I switched on you. You could have head, tail, head. You could have head, head, tail. And you could have all 3 heads. Okay, so there should be 8 possibilities here. That's player 1. Player 2, if you think about rolling 2 dice, we do the same thing. So this would be tail, tail, tail. This would be head, tail, tail, just to match. Whoops. Dang it, sorry, I didn't mean to. I was too close to the top. Sorry about that, I pulled my screen down. Head, tail, tail. You could have, the next one I did was tail, head, tail. The next one I had was tail, head, or tail, tail, head. Excuse me. Then we could have, I did head, head, tail, head, head, tail. Hopefully I'm going to make this fit. We're going to have head, head, tail, head. And we're going to have, and I'm going to have to squeeze them in. You know what I'm doing. So we're going to have, so 1, 2, 3, 4, 5, 6. We got 7. And then 8 is all heads. And so I've got them all to fit in. So this is 3 heads. This is 2 heads. And so all we want to do is when they match, well, they match here when we have each player got 0 heads. They match here, here, and here, 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 and here, 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 and here. So in that box, they've got, they all ended up with 1 head apiece. So all of those match. And then we've got the spot where they have 2 heads matching. So they match here, 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 here. And so that's everything for 2 heads. And then they also match here where they have 3 heads. And so if you count those up, there's 64 total possibilities here when they both flip 3 coins. And so if you count those, there's 20. There's this one where they match with 0 heads, this one where they match with 1 head, this group where they match with 2 heads, and this one where they match with 3 heads. And so that's 20 out of 64. So the probability of this occurring, well, it could happen 20 out of 64 times, but we need to reduce that. 10 out of 32. If you take out another 2 now, you'd have 5 out of 16. Now, I'm sure the whole reason for this also is I'd like for you guys to solve these ahead of me, is that there's got to be somebody else out there that solved it a different way. This is just the way it worked in my brain. Would love to see other solutions to that. So I hope this helps, and see you next time.